Oh, one extra thing besides this. So from here, if you reciprocate both sides, so I put it under 1, you got to swap the inequality sign, which makes sense because it's like me saying if 3 is bigger than 2, but then I decide to put it over 1, then obviously it's going to have to swap the other way. Okay, we'll be using this for one of these questions. All right, so question 6, that's basically your first question. Prove that. I'm not going to go through that because I've shown you that last time. So given this, they want you to now hence prove that. So we obviously got to use that fact to prove this. If you guys remember addition technique, so what we want to do, the first thing you want to notice is, don't worry about this side yet. We got A, B, and C, D. So what you want to do is utilizing what we've done above. Yeah, you want to add this with, yeah, and then let's see what we get. So obviously then that's going to be CD. So if I add them, I'm obviously going to get A plus B plus C plus D all over 2. And now we've got this, okay? All right, now from here, we're trying to mimic that. So, but right now I have over 2 right now. So why don't we divide both sides by 2? Yeah, because, yeah, so divide, same thing, but over 2, okay? Now this is the really hard part that I struggled a lot, because what we need right now is we need this, but right now I have this. So the challenge is, how the hell do you get from here to that? Because we've got that side, that's fine. We want to go from here in that form. So have a look at all my useful facts. X equal to, is that what you're saying? And Y? Okay, and then this one? So is this, what is it here then? This? That's right, no, keep going. That's really good. So right now I have XY. So what you're saying is replace this with this. But what is XY? Yeah? Yeah. So it's a substitution technique. It says to prove this. All right? So usually, well, what would you do? But, yeah, put them together. 2 fractions, put them together. Let's see what happens. Bring it to the other side. Can I just put it like this? If I put it together, that would be take away 4xy. This would be then squared. Is that all right? So we try to prove this is greater or equal to 0. Okay. If you simplify the top, so that's going to be x squared minus 2xy plus y squared, which is? Yeah? So if I multiply to the other side, it really just leaves me with this, and then this is true. No, in the solution they use substitution technique with very complicated. I really don't like how they did it. Okay, so we obviously want to use the first part to get to that. Yeah? Okay, what would our first step be if we want to do that? Using part A. Let me write that out. Suggestion? Look at what I have. What should you logically do to try and mimic that? Square it. Square both sides. All right. I'm going to tell you right now, you don't actually want to expand and simplify that, but you can try it on your own time because it's not going to lead you anywhere. I went through a lot of times to do that. Now, this is a good stopping point where you now go use substitution techniques. So, number 1. Number 2. And this is number 3. I'm actually going to sub in all 3 of these and see if I can try and get back to that. before I do, let me simplify this a bit. So that basically, can I write this as let, if I want to see how, the reason why I want to substitute in that is see how it kind of resembles each other. So what would I let A equals? It's pretty straightforward. Yeah, because it's whatever's inside the bracket. So if I do that, put it in there, I get this. Then 4 times that should be then this. Yeah? Okay. We're getting that, but these two, as you can see, are completely different. So let's try and substitute in a few others and see if we can get something similar. Because we're trying to get to that. 2. Same thing. This is always going to be the case for all 3. So for number 2, this one's, yeah, I'm going to get this because it's not in a bracket. Got that. And number 3. Oh, actually, you know what? What if we reciprocated this? What if sorry, you just kind of showed me something else. If I reciprocated this, then I've got to swap that. Can I use this anywhere? So if I want 2, so if I want to change this into a 2, then, oh, wow, then this has to be 8. Oh, and that's what I have. So if I replace, in our case, this inequality will still hold because I'm replacing this with something smaller. Yeah? I have this. This is greater than that. So if I replace this with something smaller, then this inequality will always still hold. Oh, so that's the question done. Okay, that's a lot smoother than I thought. So you didn't actually need all of this, so you really needed just that. Yep. Okay, so girls, this very famous, called the Herons Formula. The word actually heron comes from the word hero of Alexandria. It's actually a Wikipedia thing. I actually searched it up. It's pretty cool if you look at the history. So it's a Greek mathematician. He's actually known as a hero of Alexandria because he's invented a lot of useful things and formulas. For example, he was the first to come up with the vending machine. And he came up with this very useful formula that allows you to find the area of any triangle, right or non-right triangle, as long as you know the lengths of 3 triangles. And he showed that if you get the perimeter, so add all the lengths, divide by 2, which is represented by S, then the area of any triangle is that times the difference of that with each of those lengths. So for example, our S is obviously this, 7.5. So the area of this triangle is then 7.5 times by 7.5 take away A, which is one of your lengths. Obviously, it's going to be the same for these two. But yeah, this was a very useful discovery. That's why he's titled the hero of Alexandria, hence the name Herons Formula. Yeah, I don't know what that number is, but yeah, you'll get the same answer as if you use the non-right triangle trigonometry formula, half AB sine C. It works for any triangle. Okay, so we're given a lot of facts, right? Now, this question is actually quite tricky because you're given so many facts. It's like, where do I even start? How do I even start this? And when do I start using these given facts? You want to do it progressively one at a time, but here's your start. The starting point is actually very hard to actually see. Firstly, you want to start with this. We're given this, so we want to start with that fact. Square root of AB. Then look at this. Substitution technique. So, given just A and B, how can I replace it with, what should I let A and B here? That's the question. So let's start with this. Doesn't really matter, to be honest, but you want to let the first 2 product equal to A and the second 2 product equal to B. or you can't do that. Yep? So is equal to that. But what is A plus B? This. Okay? This, what I wrote right here already, was actually quite a tricky thing to understand. Just me writing that. It seems obvious, but not many students will be able to start that off. So that's the first given fact we want to use. All right. Now what would you do? What would you be inclined to do? Let's not touch this. That's my hint. Expand and simplify. Yeah. Think simple. All right. Well, first of all, I got this right. Second thing, S, factorize S out. And then we got this. All right, okay, now we're a bit stuck. This is a good point in time where you actually now go, let's see if there's any other useful given facts. Because sometimes students would try and carry on with this without looking back, and that's what I did. So that's a trap that makes questions like this hard. So, what fact can I use now to further simplify that? Let me circle the... Okay, actually, I don't want to make it too obvious. Yeah? Yeah. So now let's replace this with 2s. So then what do I get? 2s squared, take away that times that is 0. So what am I left with? Just BC over 2. So right now what I have, that, or, this is another tricky part, just replace it with A. Yeah, because that is the area. Okay, we're almost there. Now, remember, our goal is to get to this. We're stuck here. Suggestion? I want you to use this, yes. How though? Yeah, let's not do that. That's going to be messy. Yes, we do need to use that. Have a look at what I have. Think of the techniques we've done so far that could be used to get this. Right now we have one equation. Remember, you can have multiple equations of your own. Keep thinking. Yes, you want to add it, but what am I adding? Don't worry about the inequality. We have BC here. There's BC here. There's my hint. Oh, is that what you said?
I said if BC over 2 is that, is it like AC?
Yes, it is. That's exactly what I want you to... Yeah, that's exactly right. What's the next one? Oh, no. What? BC... Oh, AB, sorry. I'll write this as CA. That's exactly the key to doing this, actually solving this question. Okay? It's hard to see because you're coming up with your own equations. That's why I make this question really hard. All right, so let's add it. What do I get? All right, so then what would you do from here? Well, from here. What? Good, all right, we're very close. And then, basically at this stage, you're basically safe to say, therefore, A is this. You're safe to say this. Because, why? Oh, sorry, there's meant to be an equal sign here. And this is the technique I want to show you. You don't strictly always have to go by that. It's got the equal sign as well. You can't bank on that fact. Yeah? So I can basically replace this with this because it's equal. It's less than or equal. You're banking on the equal sign, therefore you got that. And that's how you do the problem. Good problem? Oh, come on. Okay, right. That's it from me.